All right, so the work that we have gotten through thus far sometimes is summarized in what they call a motion diagram to show the reader when the particle is traveling in the positive direction, when it is traveling in the negative direction. I think it's nice to actually look at it right here next to our Desmos. We know that the particle is traveling in the positive direction when velocity is positive, and that happened between 0 and 2 seconds, as well as 6 and 8. Here, my particle is traveling in the positive direction between 0 and 2, as well as between 6 and 8. And we can essentially just, the way these look is you just kind of take this curve and squeeze it on down. Here's my position function. The beginning of this story at time 0, my position is 0 meters. Then we're traveling in the positive direction up until we stop, and that's at time t equals 2 seconds. And you can go ahead and plug into the position function to get that height. It's a 32. Traveling in the positive direction between 0 and, 0 and 2 seconds. Then we know from the work that we just did down here that my particle is traveling in the negative direction between 2 and 6 seconds. In the negative direction. Right? My position is decreasing, so my velocity is negative, and that's between 2 and 6. A lot of color on the board. So the story goes thus far. At time 0, we're on the ground, and then my particle travels up to a height of 32 meters, and that's at time t equals 2 seconds, and then it's going to turn around and come back down. It's back down at 0 at t equals 6 seconds. I'm just going to write S. And then what does my particle do? It comes around and it comes right back up to the height of 32 at time t equals 8 seconds. You can plug 8 into your position function and get that your position is 32. And our Desmos animation does a much better job because it's moving to see that particle going up and down. It's telling the story. When you're doing this little motion diagram, you're drawing a picture like this, and then you're putting little arrows on it for the reader to see the up and down motion. So that right there is a motion diagram. A lot of times, I gotta make it a little smaller. A lot of times, and our textbook does this as well, instead of orienting things up, down, they'll orient it right, left. So that what would this look like at time t equals 0. My position is 0. Then at time t equals 2 seconds, my position is 32. We're turning around. At time t equals 6, we're back down at 0. Then we're turning around, and we're stopping here. 8 seconds, my position is back at 32. Don't let it throw you if it's drawn right, left. We put the little arrows on it just to show the reader the direction. But our Desmos animation does a great job helping us see that movement. I think we can do G and H in this video. So find the total distance traveled. We couldn't answer this question until we had found out when the particle was moving in the positive, negative, and positive directions respectively. So we first have to find that out, which we have. And the total distance traveled, we can just take the absolute value between the difference in the position at those moments in time where you're turning around to get positive distance and add it all up. So we're moving in the positive direction. From t equals 0 to t equals 2 seconds. So the distance traveled on that leg is going to be difference in my position function at those moments, s of 0 minus s of 2, and then if I just make it positive because I want that distance, take that absolute value, we get absolute value of 0 minus 32 meters, which gives me 32 meters. That's how much distance was traveled between 0 and 2 seconds. But then the particle is turning around and it's moving in the negative direction. And that's from time 2 seconds to time t equals 6 seconds. If I just look at the position at 2 seconds, the position at 6 seconds, and take their difference and absolute value, I'll have the distance traveled there. At t equals 2 seconds, the position there is 32 meters. At t equals 6 seconds, my position is 0 meters. So we get that on that leg between 2 seconds and 6 seconds, the particle traveled 32 meters. Right. Traveled 32, and then traveled 32 again. Moving in the positive direction. From t equals 6 seconds to t equals 8 seconds. The position at 6 seconds minus the position at 8 seconds in absolute value is a 0 minus 32. It's a 32 meters. So the total distance travel is going to be adding that all up. Adding up each one of those 32s. 32 plus 32 plus 32 is 96. And are these meters? I think I said meters, but for a second my brain thought feet. Ah, yes, meters. Good. 96 meters traveled in total. Now, total distance traveled is different than displacement. Displacement is known as a net change in position. So the difference between where the particle finished and where it started, my displacement is my position at the end of the story, 8 seconds. Maybe I'll even write that. Minus the position at the beginning. Oh, my displacement is s of 8 seconds minus s of 0 seconds. 8 seconds in, it was at a height of 32 meters. 0 seconds in, it wasn't up at all. It was on the ground. My displacement is 32 meters. Excellent.